Okay, I have a couple more examples for you here. We're going to be finding x. Now, these two examples are a perfect way to look at the biconditional statements. Remember, we had one that said that if the radius is perpendicular to a chord, it bisects it. And in this case, they're showing you that this radius is perpendicular to the chord. And in this case, they're showing you that it has bisected it and asking you what the angle should be. So here they're saying it is a 90-degree angle, and you're proving that it's bisected. Here they're saying it's bisected, and you're proving that it's perpendicular, or showing, whatever. So over here we know that x plus 6 equals 3x minus 8. Then we'll subtract the x. Add the 8. No problem. Make sure you show me this setup here and your answer. Make sure you box your answer. On this one, we know that this has to be a right angle. So x equals 90 degrees. And here it bisected the chord. It also bisects the arc. So we know that y has to equal 38 degrees. There is no work to show on this one. Okay. So for our example down here, when two chords intersect inside the circle, then the product of their parts is equal. They want us to outline these parts. AB is going to be circled in blue. These are the parts to AB. This is 27 if you can't read it, and this is 14. And CD is going to be outlined in green. This right here is X. I'm not sure you can read my green pen either. And this one here is 21. And now we're going to solve for X. So this is one where I can show you a little bit of, math shortcut, I guess. So we'll take 27 times 14 equals 21x. Now, we know over here in our thought bubble, let's talk about 21 factors into 3 times 7, yes? So when I divide by 21 both sides, over here I'm going to write it as 3 times 7. What I can do is I can divide, because this is just multiplication between here, I can divide the 3 into the 27 and get 9. And I can divide the 7 into the 14 and get 2. Everything else in this fraction is gone, and I'm left with 9 times 2, which is 18, equals x. So that can save you from doing a little bit of extra math if you don't have a calculator. If you do have a calculator, obviously you can choose whether you want to do it the fun way or do it with the calculator. It's up to you. Our next example is when two secants meet outside the circle. Now, we just did something similar to this with angles. Now we're doing it with line segments. So when the two circles meet out, or when the two secants meet outside the circle, we're going to take the outside times the whole equals the outside times the whole. So in this case, it'll be QR times QS. And you have a typo on yours. It says UT right here. It should say QT. So then it'll be QU times QT. Well, QR is just 7. QS is 7 plus 9. QU is 8. And QT is x plus 8. So we have 7 times 16 equals 8 times x plus 8. Now again, I can do a little bit of a math shortcut. I can divide both sides by 8. Here that gets to 1, and here I get a 2. So that simplifies my math a little bit. I have 14 equals x plus 8. Subtract the 8, and I get x equals 6. On this one, I definitely need to see your setup and your answer. I understand if you put it in the calculator. Okay. Now, if you've got that same situation, except that one of them is a tangent, you can see it doesn't go through the circle. So when you take outside times the whole, you're really just squaring this term. Okay. So you'll have LM times LN equals LO times LO. So 12 times x plus 12 equals 18 times 18. When I decide to work this out, I can turn my 12 into, I don't know, 6 times 2. Divide that over here. Then I'll have x plus 12 equals 3 times 9. So x plus 12 equals 27. I subtract the 12, and I get x equals 15. There's that example for you. So down to our last page of notes. I'll go ahead and throw them in here. And make sure you read these little hints that I've got around in your notes, because they are pretty important. I do mention them, but sometimes you don't always hear all the details. So if we're finding a segment and the cross happens inside, remember it's this part times this part equals this part times that part. So here we're going to have 9 times 2x plus 2 equals 15 times x plus 2. In this case, I know 9 and 15 are both divisible by 3, so that'll give me a 3 here and a 5 here. So that becomes 6x plus 6 equals 5x plus 10. Subtract my 5 over here and my 6 over here, and I get x equals 4. Okay. And down here, we get to practice this one. And this is a great one to practice because you have to remember that part, and then when we're doing the whole, we have to add the 5x plus 1 plus 9. Okay, so this will be 9 times 5x plus 10 equals 10 times 4x plus 10. So this will be 45x plus 90 equals 40x plus 100. I'm going to subtract the 40 this way and the 90 that way. We'll get 5x equals 10, or x equals 2. Make sure you show me the setup and your answer. Make sure you box your answer. Best of luck to you.